Today let's try to solve another Leetcode problem, 907, sum of subarray minimums. So we are giving an array. Inside of the array, it is the positive numbers. So we want to find the sum of the minimum subarrays. So this means for this example, we have the subarrays. So the subarray is continuous. It has the 3, 1, 2, 4, so and others. So we're gonna sum the minimum of all those subarrays. So the brute force is on. You're gonna need 2 for loops, and the outer loop is to loop through each. For example, loop through the first index, and then use another loop to check. The inner loop to check one by one the minimum numbers. So for the first number we checked, and then go to the second number and go to the third, but this will be an on square. And for n, it is 3 times 10 to the power of 5. It means on square is not possible. So we have to try to find a on solution to solve it. So let me copy the array and try to analyze it here. So it is 3, 1, 2, 4. So we have like array 3, 1, 2, 4. So basically for those 4 numbers, so this is the index 0, 1, 2, and 3. So for these 4 numbers, we want to get the minimum subarray. So the idea is we're gonna enumerate each one of the numbers. So for example, we're gonna enumerate from the left to right. So for this first number 3, we want to find what is the range, the minimum window for this 3 from the left side and the right side. The minimum number is still this 3. So for the right side, we cannot go more. It is 3 because there's no numbers. But for the left side, what is the minimum number that is less than 3? Because if it is more than 3, so inside of the window, the minimum number will not be 3, because we want to calculate the value inside this window for the left and right. We can expand to the right and expand to the left and expand to the right. We want to find the minimum number. It must be 3. Otherwise, the enumerate didn't work, because we're gonna enumerate each numbers, and for each numbers we're gonna find the left window and the right window. But inside of the window, the minimum numbers would always be 3. So for the left, there's no numbers. So if there's no numbers, what we should do? We should give it a -1, because we will use index. For this index 0 minus 1, it is 1. It means for the left side, we find one number. It is itself 3. And then it's gonna expand to the right side. If it expands to the right side, what is the first number that is less than 3? So it is this 1. Now we're gonna have a record. We're gonna have a left array and right array. So for the left array, we're gonna initiate always be -1. And then we're gonna update the left and right. And for the right, we're gonna initiate array. It's gonna be always n, the length of the array. Why? Because we're gonna use this -1 and this n just for the easy calculation, while we are using the algorithm to solve it. So the algorithm actually is a monotonic stack. So let me explain this in a monotonic stack way to solve it. So we're gonna prepare 2 arrays, left array and right array. So for the left array, we're gonna prepare for each of the numbers, what is the minimum number to the left side that is less than 3. Because there's no numbers, we're gonna give a -1, and then we're gonna check this number 1. What is the minimum number that is less than 1? So there's no such numbers, so it will be -1. And then we're gonna check this 2. What is the minimum number to the left side that is less than 2? So we find a minimum number. So it is 1. So what is the index for 1? So the index for 1, it is the index 1. So this minus 1 gonna be updated to 1. And then we're gonna check this one, this 4. What is the minimum number to the left side? It is this 2. And what is the index? It is the index 2. It is the index 2 for this number. Yeah, now let's check the right side. I didn't find an eraser to erase it. Yeah, now let me just update the left array and right array. So for the left array, it is minus 1, and this is index 1. And for this number 4, it is for this number 4, it is index 2. And now let's check the right array. So for the right array, it's gonna be n if there's no such numbers. So for the right array, we're gonna check from the right to the left side. So for this 4, as there's no such numbers for to the right side that is less than 4, so it will be n. So n will be 4, and then we're gonna check 2. Yeah, we didn't find a smaller number to the right side, so it will be 4. And then we're gonna check this one. To the right side, what is the minimum number? So it will be 4 because we didn't find the minimum number is less than 1. And for this 3, so for this 3, we're gonna check to the right side. Yeah. So what is the minimum number? What is the number that is less than 3 to the right side? So that is 1. So the index, it will be 1. Yeah. If we get the left side and the right side index, yeah, we can just use this left array and right array to calculate the result. But how did we get the left and the right? We used the monotonic stack. Yeah, because all the numbers is continuous. So that is why we can use the monotonic stack to find the left and right index. And after that, we just use the left and right index to calculate the result. So for example, for this 3, because the left index is minus 1, so we're going to just use this index 0 minus 1. So it is 1 times the right index, it is 1. So the 1 minus 0, it is still 1. Yeah, 1 times 1 and times this number. So this means for this number 3, the window is itself. So the result is just 3. Yeah. And we can also use the similar way to calculate all those numbers. Yeah. But the difficult part is sometimes there will be 3, 1, 2, 4, and there will be another 3. We're gonna have the duplicate calculations. So yeah, to avoid the duplicate calculations, we can just use for the left side, we can use the monotonic stack to check. So for example, for this left side, we can let it include this 3 index. So the index is 4. We can include this index for the left side. But for the right side, we will not include it. Otherwise, it will have the duplicate. So for example, for this 3, if we are going, yeah, this is not a good example, but yeah, but I will use later on. I will use another example to explain the duplicate. Yeah, duplicate case. Now let's go to the code editor to finish the coding. Basically, we need to understand why the monotonic stack works, because it is similar like a sliding window. We need to find each number to the left side and the right side, and the monotonic stack can find the the number which is the first number to the left side, or the first number to the right side, which is less than the current number 1. Yeah, so we're gonna prepare a stack and the left and right array. So the length of the array would be the length of the array itself. So the left would be -1 times n, and the right array would be n times n. So this is just for the preparation. Now we can start the monotonic stack. We're gonna also prepare a mod, because the result will be modular 10 times 10 to the power of 9 plus 7. Yeah. Now we can start. So let me take out this stack, because I will use it twice. So for the first time, I'm gonna prepare an empty stack, and now I'm going to enumerate for the left array. So for I will enumerate the array. So I'm gonna check it while stack, and the stack array I. So inside of the stack, the number inside of the stack, if it is more than and equal to v. So for this example, so the current value v is 1. Yeah, if this number inside of the stack, it is 3. If this 3 is more than and equal to this 1, so I will take it out. I will pop it out from the stack, because I will not use this index. Yeah, because I want to always find the number to the left side, which is less than the current number 1, but this 3 is more than 1, so I need to pop it out. So the stack would be pop. Yeah. If I pop it out, I need to check if there's still numbers inside of the stack. If there is, so I will update the index. So the left I would be stack -1, so it is on top of the stack. And finally, I just need to use the stack to append the numbers if everything is okay. Yeah. Inside of this, because inside of the stack, it is always a monotonic increasing stack. So for example, the first index, it is -1, and then it is inside of the stack. For this stack, it is so for example, I'm gonna use this example to explain the stack. So for the first number, the 3 will be inside of the stack, and then it goes to 1. Yeah, if it is a decreasing stack, 1 will be just appended to the stack. Because this number 3 is more than and equal to 1, so it will be popped out. So after popping out, it will be 1. Yeah. So for the next number, if it is 2, because the current stack number it is 1, 1 is less than 2. Yeah. So it will not execute for this line, and the numbers will be just appended inside. So for the next number, it will be 2 and 4. So this is why this is a monotonic increasing stack. Now we prepared the left array. We just need to prepare the right array, so it will be the same. But for the right array, it will be from the right side. So for I in range length of array, it will be n -1 and -1 here. So similarly, we will do the same things. Yeah, we just need to copy the code and do the same things. So while the stack exists, and this stack I more than and equal to v, and we just need to pop it out. And here, just need to update it to the right. array. And after that, it will be the same. And finally, we just need to return the result. So the result will be the left side times the right side times the current number v. So for iv, enumerate the current array. Yeah. And for the left side, actually it is the I minus left I. And for the right side, it is the right I minus I. Because for the left array, it is always find the index from the left side. So that is why we can use I minus the left I. And for the right side, it is always find the index to the right side. So we can use the right I minus the I. Yeah. Now let me just run it to check if there's something wrong. So list index out of range. Yeah, because here it would be -1, it's not I. Yeah, this is just the monotonic stack template code, which should always check. It's not. I think it's a stack. Yeah, it is not like this. I did something wrong. It is. We need to check the numbers. It should be array stack -1. I made a mistake. So let me copy the same code from here. Yeah, because we want to check the numbers inside of the array. This stack is for the index, and this is the number. Yeah, because here is not v, here is array I, because we don't have this v anymore. Array stack -1. And let me check this index. Oh, here I did something wrong. It is not append v, it is append the index. Now let me just run it to check. Yeah, now at least it passed some of the testing cases. It means basically the code should be right. Now we need to avoid the duplicate, because for here it is more than equal, here more than equal. It means we have some duplicate. So for this example, we're gonna use this example, 71, 55. Yeah, so for example, for this 55, we're gonna check the right side. Yeah, so if we want to include this 55 to the left side, yeah, we cannot include it to the right side. For example, while we are checking this 55, yeah. So the window to the left side cannot go to this 55. Otherwise, there is a duplicate. Yeah. So this means, yeah. So for this example, for this 55, if we count to the right side, if we include the 55, include the number equals to it, we're gonna have this kind of a window, 55, 82, and 55. If we're gonna check this 55, if we wanted to include the left side, this 55, it's gonna totally the same. So in order to avoid the duplicate, we have to include 1, not 2. So this means for here, we have to use more than. Yeah, it means for the left side, we will not include it. And then the right side, the right array, we have to include it. Yeah. Now let me just run it to check. Yeah, as you can see, it works. Now let's just check this kind of result. Why it is I minus left I times right I minus I and times v. Yeah, this is just the enumerate idea. We just need to enumerate all the possible results. So for this example, we're gonna so I'm gonna use just this example to check one example again. So for this number, for the second number, for this number 1, so if we wanted to count all the possible cases, so for the left side, how many cases? It is 1, 1, and 3. Yeah, it is 1, 1, and 3. Yeah, so there are 2 possible cases. And now, what about to the uh, right side? So the minimum number is still 1. So it include if we count from this one, if we're gonna count start from this one, it's gonna have 1, 1, and 2. It also have 1, 2, and 4. 1, 2, and 4. Yeah. So this means we're gonna use how many possible cases for this? If we just count this one. So for the left side, there are 2 possible cases, and for the right side, there are 3 possible cases. So we're gonna use 2 times 3 and times this number 1. So why it is 2 times 3? Because if we code it one by one, so for this one, it's gonna have 2. 1 and 1, 1 and 3. And now, if we want to, this is only for 1. Now, if we are going to check this 2, so for this 2, it will include 2, 1, and 2, 1, 3, so there are 2 cases. And for this 4, it will be 4, 2, 1, and 4, 2, 1, 3. It will be, another 2 cases. So this is why it is 2 times 3. This is just to enumerate all the possible cases. Now let me analyze the time complexity. So because this is basically to solve the problem, and even we have 2 stack and 2 a for loop and while loop, but this is just on time. Because for this monotonic stack idea, actually we just use the pop the index, append the index and pop it out. So we didn't use any actual time, and the space complexity is also on because we just use the 2 stack. We just use the 2 stack array. And also we used the left and the right array, but it is on space complexity. Now let me just submit it to check if it can pass all the testing cases. Because finally I didn't use the mod because the result needed to have a mod. So I needed to use a mod because it's a really big number. Now let me submit again after modular the mod. As you can see, it passed all the testing cases. Thank you for watching. See